Welcome to how to graph and interpret the units. That is not part of the graph. There are some information we first need to apply or fill in. Those are just to as a reminder of what the appropriate steps are for these variables. So first, time body mass is in the for this random subject. This is power output is in the unit of watts. This is 100% random. We're going to go with a body mass of 75 kilograms to help us calculate. We know their sprint times. We're going to input those now. So time is in the unit of seconds, power output is in the unit of watts, 4.88, 5.25, and finally 5.12. Here, we can apply a simple formula to identify the power output, and then we'll be able to do a nice click and drag. So we do need to reference constantly throughout the rest of these cells the body mass. So this is cell B1, so $B, $1. Then we are going to multiply this by the distance. Now the distance between the gates is 35 meters. So for this we are not including the extra 5 meters of slowdown space on each side of the testing field. So 35 squared divided by the time, so we can just highlight that cell. And we are going to cube that. Hit enter. If when you hit enter or accept the formula, you may find that you have multiple decimal points. In order to reduce the number of decimal points, you can come up to the number section, 00.0 with the arrow pointing to the right, and you will find that you're able to reduce the number of visible decimal points. Now, because we have highlighted that we want it to constantly reference the cell B1, we can click and drag, and the formula will be applied to the remaining sprint times. In order to graph this, we've set it up very nicely. So we have the variables we're looking at on the left, and we have a merge. This is very important to have this merged for sprint number. We can highlight all of those things, come up top for insert, line graph, and we'll have a nice preview. Now you can see that when we initially create the graph, time is way down here near 0. Interpret this visual representation. So we can left click just to select, then we're going to right click. Format data series is one option we can go, or the other option we can do is change series chart type. So I'm going to go with this one first. And down here, you can see series name time or power output. We can keep it as a line graph. And we're just going to select which variable we want on the secondary vertical axis. So we are going to go with the power output. Now you can see power output, the much higher numbers from our table are listed on the right. And just to demonstrate the other way to go about this, format data series, we'll have the box pop up here on the right. And because we selected the variable for time, that's what this is going to apply to. So we're going to put time on the secondary axis. Now we need to make sure that we have the units in place. So we can go to this little plus button, which is chart elements, or if you don't have this identified when you click on the overall chart, you can come up to the top left where it says add chart element. I believe this is more prominent for the Mac users to have to go this route. Either way, we can go axis titles. And now that we technically have 3 axes that require labels, the primary horizontal is already labeled with sprint number. So we don't need to worry about the horizontal label. We do, however, want to make sure that we have axis titles for the primary vertical and secondary vertical. So we can go primary vertical here, if you're going the chart route, or the Mac route, or if you do have this plus button here, you can select that. You've selected axis titles, expand it, and you can select multiple axis titles at the same time. So now that we have the space for the axis titles, we need to make sure we include the proper units. So we know that power output has a much higher value than the time value. So we know that this is going to be power output. And the unit for that is watts. And you can recall this from the little note over off to the left. And now we're going to label for time. And that is in seconds. And finally, we are going to apply a chart title. So the appropriate title for this would be Repeated Anaerobic Sprint Test. And yes, do spell it out. Hopefully better than I can. Perfect. So now we have a nice, neat chart. We like the look of it. How are we going to then apply this in the Word document? You can select the actual graph. Just click anywhere, not anywhere specific. Click in the general area of the graph. Copy command. Open up your Word document. 7.2 minus the lowest power output of 634.92. Going to close those parentheses, divide it by the total time, and that's going to be 7.98%. Make sure when you apply this calculation, don't come up and select the percent, because if you do, that's going to say there was a 798% change, when in reality, it's just the general 7.98% drop of power output. So between all of this, it was a loss of 7.98% of performance. For your activity sheet, it directs you to identify the relationship between power output and time. If you look at the graph that we've made, you can see that there's in fact an inverse relationship. So as time decreases, power output increases. And as time increases, power output decreases. So perfect example. Time is nice and low over here. Power output is nice and high. Power output decreases as time increases. So you can see that there's that nice inverse relationship throughout. However, you may also notice that the change between sprints 4 and 5 for time is a bit steeper of an increase than the relative decrease in power output, and that's just due to the actual formula applied when calculating power output. But the general idea is that there is an inverse relationship between the two variables. Now, for the lab report, you'll see that the instructions identify that we would like for you to graph each of the power outputs for the individual subjects for each of the 6 sprints. So that ultimately we're looking to have 10 different lines identifying the power output of each sprint for each subject. In order to lay this out, we're providing just 3 subject examples here, so not all 10, and again, these are just random numbers. Once more, it's very important how you set up the table. For the sprint numbers down here, you want to make sure that the row above has merged cells. So if you have not merged before, you can put sprint number in any of the 6 cells above. Click and drag, highlight all of them, and right here you can come and merge and center, and we have that there. So that same skill was applied in merging subject number versus sprint number. So we don't necessarily need to spell out number, because when you see how the graph will turn out, it works quite nicely and it's quite clean. So nice and easy, we've got this set up. We have subject 1, 2, 3. You guys will have through 10. We have only 6 sprints. Those are identified here. And all of these power outputs will be filled in or you guys will have to calculate all of the different power outputs for the 10 subjects. But again, we're just using an example of 3 subjects for ease. You can literally click and drag to highlight everything. Come up to Insert. We're going to go with a line graph once more. In here we have the sprint number easily identified, 1 through 6. Subject numbers, they all have their own color for their line. But once more, we are missing some information on this, so we need to update the chart title. And this will be individual power outputs. We need to include the axis titles. So we're going to come to our chart element option, axis titles. We only need the primary vertical because we are not applying a secondary axis. We're only working with power output. We are not including time. So power output. The unit for that is a big W. And we are happy. If you would like to scale, you may double click on the axis values. Right now the minimum is set at 0. However, because we will have so many individuals' information posted, we may want to select a minimum value that is slightly below the lowest power output. So let's go ahead and just go with 500 for this example. And we're able to see in greater detail the differences between the power outputs of the individuals. Now, 872 and 873 are very close, so for sprint 1, these two individuals had a very similar time, and we were able to see that in sprint 1, they are basically overlapping. We can also see that subject 1 had much greater changes in their sprint-to-sprint time and power output versus the more steady decline of subject 3 in gray. We can see that also by looking at the data. Each time the value decreased, whereas for subject 1, they had some sprints that were faster, so a higher power output. Some sprints were slower, a slower output, but they were not fashioned linearly. So they're a little bit more sporadic, like sprint 5 is slower than sprint 6. That will impact how this graph looks. Just as before, for the lab report, click in the general area, copy, paste it into the lab report. Remember that the visual section or the visual representation of the data comes after the narrative of the data, so not before. Explain it before you give the visual.